Now, after this happened, they got some more weird things coming up. They predicted that there might be extra dimensions. Dimensions outside the 3 spatial dimensions that you're aware of, and the 4th time dimension. Now, these dimensions might be just mathematical dimensions, because when you add extra dimensions, it actually makes the math easier in this situation, rather than using only the 4 dimensions and having to integrate different charges, different spin, all these other things that you'd have to integrate into it without these extra dimensions. So there are some string theorists who believe that there are extra dimensions, and there are some that aren't, that don't believe this. And this is one of the arguments that they're having right now about it. But one way you can kind of visualize extra dimensions is if you think of, just think of an ant on a pole. It's kind of a stupid metaphor, but or you can be a person, sure. Now, you've obviously got this spatial dimension where you can go across the pole. That's obvious. You can go back and forth. Now, one other dimension you have is you can go around the pole. Now, that is basically one of the ways that they're saying that these dimensions can occur. Is that at every point in our universe, there exists not just points, but circles. That would integrate the 5th dimension. Now, what if these were spheres? That would integrate the 6th dimension. Now, you can keep going to more complicated shapes, and what they end up looking up like at the 11th dimension is basically just weird squiggles. You have no way of understanding what the geometry is like. I think they call them Calgary-Yau shape here. Alright, yeah. And so yeah, that's where it was at this point. And what ended up happening is string theorists got kind of carried away. They ended up with 5 different theories. Some of them required open and closed strings. Some of them required just open or closed strings rather than both at one. And others required 26 dimensions. Now, many people do not want to accept that there's 26 dimensions, including physicists. They think that's ridiculous. That doesn't make any sense. So what Ed Witten did, he integrated all these 5 string theories by incorporating an 11th dimension rather than 10 or 26 as they had originally been. With this 11th dimension, he was able to name the string theory the M theory. And M theory, nobody really knows what the M stands for. Many people say magic. Some people say membrane, because when you add strings to the 11th dimension, they become membranes, rather than just 1D objects. And some people call M the murky theory, because it just doesn't make much sense. And that's how some people think about it. That's what critics call it, murky theory. But what this M theory tells us, even though we don't understand it completely yet, we have the map, but we can't integrate with our world that easily. What it's suggesting is that our 3 dimensions exist on a membrane that consists of 3 dimensions. This membrane is floating among the other higher dimensional space, and we can't see these other dimensions because they are so minuscule. They are within each singularity of our universe. You can't even see at that level with technology. And this also allows for parallel universes, because what happens when one of these membranes collides is you end up with the equations that describe the Big Bang. Now, what this suggests is that Big Bang is not very uncommon. It happens all the time. Our Big Bang happens to be special because the way that it happened, the way that this collision occurred, happened to create the variables that we know, or the constants that we know. There's about 20 universal constants for each universe that you can imagine. And tweaking each of these variables or constants will result in a different universe, such as how strong is gravity, how strong are the other forces, and among other things. So, for example, if gravity weren't strong enough, then the universe would just expand and nothing would go back to the no planets, no stars, anything like that. Now that's M theory, and this is a great thing. This was really exciting to the physicists that were working on it, because if they could describe the Big Bang with this theory, then what else could they describe? They could describe many other things, such as black holes. Black holes are known as, they have event horizons, and past that event horizon, nothing can escape, even light. We know this. But what Stephen Hawking did was to predict that black holes emit radiation in the form of heat, and we had no map at the time to predict how this would be, but this makes complete sense, because if black holes didn't radiate anything, then it would just be matter destroying itself, and you lose matter out of the universe, and that doesn't make physical sense. Because where would it go? It just disappears, doesn't it? Now, string theory is the only theory thus far that can describe this Hawking radiation, and because of this, many are latching onto this as a very hopeful theory to explain the universe. And